The Idaho Transportation Department is implementing a reduced speed zone in the wildlife corridor between Albertsons Market and Zinc from 55 miles an hour to 45 miles an hour during nighttime hours. And here at Wood River High School, in Mr. Tsai's applied physics class, we broke up into groups and ran a series of experiments to conclude whether driving at 45 miles an hour is going to be safer for drivers. This is what we found.
My group researched reaction time, the time it takes from someone to move, to figure out what's happening and move their foot from the accelerator to the brake when confronted with an unknown situation in front of their vehicle while driving. A second and a half is the number used by accident reconstructionists, although this number can be greatly varied by other factors, including poor visibility or inattentive driving, although we did use 1.5 seconds, which is the average reaction time for the average person.
Our group's objective was to find out how far we could see at night with our dim headlights on. And after a lot of research, we found out that the distance we could see at night with our dim lights on was 150 feet.
Our group was in charge of figuring out if we will hit the deer going 45 miles an hour, and if so, how fast would we hit the deer. We did the calculations using the kinematic equation velocity final squared equals velocity initial squared plus 2 times acceleration times distance.
We found out that by the time our foot reaches the brake, we will have traveled 100 feet.
And we will come to a complete stop at 172 feet, but since we only have 100 feet, we will be 20 feet into the deer and we will hit the deer at 22 miles per hour.
Our group was calculating the reaction time, reaction distance, stopping distance, and end collision speed when traveling at 55 miles per hour on the highway. Now, when you're driving along with dim lights, you notice a deer at 150 feet away. There's a period of time called reaction time, where you see the deer and you begin to take your foot and begin to apply the brake. During that distance, you will have traveled 120 feet before you even begin to stop. Now, when you begin to apply the brake, it takes 110 feet for you to come to a complete stop, meaning you've traveled a total of 230 feet since you first saw the deer. The deer was 150 feet away, which means you went 80 feet past the deer. Now, with a deceleration rate of 30.4 feet per second, you will have hit the deer going 48 miles per hour. This is assuming you reacted perfectly. You saw the deer right away. You began stopping as quickly as possible. So the likelihood that this would happen is pretty slim, but even then, you're hitting the deer almost less than 7 miles per hour than when you started.
My group's responsibility was to figure out the time difference driving in the nighttime speed limit zone. This zone stretches from the Albertsons stoplight to the Northern Buttercup turnoff. We used 2 different methods to calculate the difference in time, calculating the distance based on the odometer, calculating the distance based on a stopwatch. Based on the odometer, we found the distance to be 2.75 miles. And when we calculated based on the odometer, we found the time difference to be 40 seconds slower. When we did the stopwatch, we found the time difference to be 42 seconds slower. So we averaged those times, and your overall time difference through the speed limit zone is 41 seconds.
Wildlife collisions are definitely one of the most common types of collision that I see up here, especially working in the Wood River Valley. I probably, during the peak in the fall and the winter, we're going to get one every couple of nights. I do believe that the slower travel speed would help avoid some of these collisions. It's just basic physics, where if you're traveling at a lower speed, you're going to be able to stop in a sooner distance. You're going to travel less distance in your reaction, in your reactionary time. So I think slowing down would help avoid some of these collisions.
So, is driving 45 miles an hour at night much safer than driving 55? Our research shows that while driving 55, you will hit an animal at approximately 50 miles per hour. Whereas driving 45 miles an hour, you will hit an animal at approximately 22 miles per hour. Although a collision at 50 miles per hour is about twice the speed as 22 miles per hour, the impact is 4 times as great. This is because the velocity is squared in the energy equation. Another way to put it is that driving 55 miles per hour at night will produce a collision with the animal that is 4 times as destructive. Due to these findings, we conclude that the reduced nighttime speed limit of 55 to 45 miles per hour is much safer.